right, so continuing with some examples, we have the natural log of 3 minus x plus the natural log of negative 2 minus x. And that's going to equal the natural log of 1 minus 7x. So again, the first thing that I notice is that I am starting in log world, so I better check my answers. The second thing I notice is that I've got logs equal to logs. So I need to get a single log equal to a single log. So that gives me, if it's two separate logs joined by addition, it's going to be a single log joined by multiplication. So negative 2 minus x, and that's going to equal the natural log of 1 minus 7x. And now, that was a lovely parenthesis. Now that I've got a single log equal to a single log, I can actually just focus on the arguments because I've already got the natural logs in place. So if I want the left to equal the right, I've already got these here. Those pieces are complete, but now I need to focus on these pieces. So I've got 3 minus x times negative 2 minus x, and that needs to equal 1 minus 7x. So I'm going to FOIL this out. So 3 times negative 2 is negative 6. 3 times negative x is negative 3x. Negative x times negative 2 is positive 2x. And negative x times negative x is positive x squared. And that leaves me with 1 minus 7x on the right. So I'm going to combine like terms as well as put this in descending order. So I've got an x squared minus an x minus 6 equals 1 minus 7x. So since this is quadratic, bring everything over to him so I can see what to do from there. So I'm going to subtract 1 from both sides, and I'm going to add 7x. Sorry, add 7x to both sides. So now I'm at x squared plus 6x minus 7 is 0. So now I need to see if it's factorable. So do I know two numbers that multiply to negative 7 that add up to positive 6? I do. X plus 7, x minus 1, which means if those are my factors, my solutions would be negative 7 and positive 1. But we need to check our work. So I'm going to put a negative 7 in first. So I've got the natural log of 3 minus negative 7 plus the natural log of negative 2 minus negative 7 equals the natural log of 1 minus 7 times negative 7. So I'm just taking my original problem and subbing in negative 7s just to make sure nothing goes to 0 and make sure nothing goes negative. So 3 minus negative 7 is the natural log of 10. Negative 2 plus 7 is the natural log of 5. And then 1 minus 7 times negative 7 is going to be what? 1 plus 49, which is 50. So natural log of 50. So positive, positive, positive. Not 0, not 0, not 0. So negative 7 works. So now we're going to try 1. So the natural log of 3 minus 1 plus the natural log of negative 2 minus 1 equals the natural log of 1 minus 7 times 1. So the natural log of 2 plus the natural log of negative 2 minus 1 is negative 3 equals the natural log of 1 minus 7 is negative 6. So positive and not 0. Not positive. Trash. So 1 does not get to be an answer. So negative 7 works. All right, so let's try another one. We have log base 8. So this is not a natural log. This is not a common log. Natural log has a base of e. Common log has a base of 10. And this is going to equal log base 8 of 15. All right, so what's my basic setups? I've got logs on both sides, but I need a single log equal to a single log. What else do I notice? I am starting off in log world, so I had better check my answers for extraneous solutions. So I'm going to combine my two separate logs that are joined by addition, and I'm going to put them together using multiplication on the inside. And that equals log base 8 of 15. So now I got a single log equal to a single log. So grab your arguments and set them equal to one another. And now we solve. So I'm going to FOIL this out. So x squared plus 5x plus 3x is plus 8x plus 15 equals 15. And now I'm going to subtract 15 from both sides because I want to get this thing equal to 0. So x squared plus 8x would be 0, and now I factor. So factor out an x, and that leaves me with x plus 8 is 0. So my two solutions are 0 and negative 8, but we better check our work. So I've got 0 plus 3 is 3. We're good. Okay. 0 plus 5 is 5. It's not 0. It's not negative. We're good. So 0 works. Now let's try negative 8. So negative 8 plus 3 is negative 5. I cannot have a negative for my argument, and I cannot have 0 for my argument. So negative 8 is extraneous. So I have a single answer of 0. All right, I have log base 4 of x squared minus 21, minus 121, sorry, minus log base 4 of x plus 11, and I need that to equal 1. So what is my setup? My setup is logs equal to something else. I need to check my work, okay? So I need a single log equal to something else, so I need to combine these. If it's subtraction on the outside, it is division on the inside. And now this is going to reduce because I can factor the top. So I'm going to factor the top, and I'm going to get x plus 11, x minus 11 over x plus 11 needs to equal 1. So any number divided by itself is 1. So now I've just reduced this to be the log, the common, oops, sorry, I've got my 4s, oh my goodness. Log base 4 of x minus 11 needs to equal 1. Okay? So now I've got exponential format because I've got a log equal to something else. So I am going to change him to exponential. So 4 equals x minus 11. So I'm going to add 11 to both sides. So I get 15 equals 11. So I need to check my work. So 15 squared is 225. 225 minus 121 is positive and not 0. So I'm good. Okay? 15. 15 plus 11 is 26, which is positive and not 0. So I'm good. All right. So now we have a paper that will not turn. We've got log x, which is in base 10, plus the common log of x minus 22 is going to equal the common log of 75. So I could say log base 10 of x, log base 10 of x minus 22, log base 10 of 75, or I can say the common log of x. The common log of x minus 22, the common log of 75. So I've got logs equal to logs, which means I need to check my work. And I've got multiple logs equal to a single log, so I need to condense. So join by addition on the outside means join by multiplication on the inside. So now I'm going to go ahead when I pull this thing, well, I may as well. All right, so I've got x times x minus 22 is 75. That looks like division because my ink bled through. That is not division, it is subtraction. So x squared minus 22x is 75. So I'm going to subtract 75 because I know that this is quadratic, so I'm going to have to factor. So now I need two numbers that multiply to negative 75 that add up to negative 22. So that's going to be x minus 25 and x plus 3. So my two solutions are 25 and negative 3. So I need to check my answers. So we're going to push 25 through. So 25 is positive and not 0. 25 minus 22 is 3, which is positive and not 0. So 25 works. Let's look at negative 3. Well, as soon as I plug in a negative 3 here, it's gone because the log of negative 3 does not exist. So that is already gone. If you were in doubt, then negative 3 minus 22 is negative 25. Doesn't work. Okay, so you've got a single solution, and it is 25. All right, so let's try some with natural logs. So our process is still the same. It's just that our base is going to be e equals the natural log of 10. All right, so what do we have? We've got multiple logs equals a log, so I know I'm going to have to check my answer. I need to condense this. So multiple logs joined by subtraction, I can rewrite as a single log joined by a division, sorry. So now I've got a single log equal to a single log. So I'm going to go ahead and write my arguments equal to one another. And now I can cross multiply. So that's over 1. So 9x plus 10 equals 10x. This is not quadratic, so I'm going to subtract 9x from both sides, and I get 10 equals 1x. So I need to find out if this satisfies or not. So 9 times 10 is 90, plus 10 is 100. 100 is positive, 100 is not 0. So far we're good. Substitute it in here. That's just a 10. Nothing is going to happen to him. So since he's just a 10, 10 is positive and not 0. So we're good. So my solution is 10. All right, so now we're going to go back and we're going to hit some with interest. And what we did in a previous section was we used exponential forms to solve interest formulas, but now we're going to have to go into log world to find out what's going on. So how much money will there be in an account at the end of 5 years? Okay, if $10,000 is deposited at 5% interest and it's compounded semi-annually. That sounded so weird. I said semi instead of semi. Semi-annually. All right, so I'm going to use this formula of A equals P times 1 plus R over N raised to the NT. So what do I know? What do I not know? Semi-annually means twice per year. Okay. Remember that your interest rate needs to be in decimal form. So I want to know how much money will there be? How much am I going to achieve? So I'm solving for A. I'm starting with $10,000. I've got 1 plus my rate, which is 0.05, over the number of compounds per year, which is 2, raised to the number of compounds per year, which is 2, times 5, which is the number of years that we're doing this for. So where's your variable? My variable's over here, which means I can throw this entire thing into my calculator. So I now have 10,000. 1 plus 0.05 divided by 2 is going to be 1.025. 1 plus 0.05 divided by 2 is 1.025 raised to the 10th. So I'm going to raise that to the 10th power. I get 1.28008 0084544. And I'm going to take that times 10,000. So my answer is $12,800.85. And that is how much will be in the account at the end of 5 years. So I'm going to stop it because that was an easy one, and the next one we're going to have to dive into logs.